Good morning, chat. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and for once we are actually going to be programming. It's been a while since the Cursed Coding series. The last time was back in April of 2024, so it's been over a year. This is the kind of thing that I wanted to do a debut, and I haven't been doing a lot of it, mostly because I don't have any ideas. But today, I did come up with one, and what if we had no parentheses? Here are the rules here. So we can't use any actual parentheses, and we can't also derive any parentheses either. So we're gonna have to figure out how to do things like function calls and if statements and loops and all that without them. Function calls, I would say, are probably the most difficult. But anyway, let's say hello to chat here. Apple, welcome in. A little bit early there, but hopefully you're here now. Part 9, also welcome in. Only now heading to the hardware store, not long before closing. I hope you get there in time. Just missed my stop in reverse. Read the map wrong. Got off too early because I thought it was too late. Well. Still hope you get there in time. After, yeah, welcome in. Okay, so our challenge here is that we can't use parentheses in any form, either in the source code, escaped, or we can't derive any parentheses either as a string, for example. So we're actually going to have to figure out how to do this without any form of parentheses. We're allowed to use anything else, but no parentheses. And so let's go over the different kinds of things that might make this difficult. In JavaScript, for conditionals, you have if statements. Set ft equals JavaScript. You have if statements here, right? Those use parentheses. You have for loops that also use parentheses. You have while loops that have parentheses. You have function f. So function declarations, those all have parentheses. You have function expressions, which have parentheses. You have function invocations, which have parentheses. What else is there? You have expression grouping. A plus B, for example. This one I think should be fairly easy to work around. But the invocation I think is probably going to be the hardest part, because for ifs you have conditionals, you have ternary conditionals rather. So you have if A then B or C. For loops you have recursion, which requires a function call. But you also but that's something we can figure out later. So there's recursion, but there's also the array methods. So things like for each, or map, or reduce, or things like that. So array.prototype for each. For the while loop, we also have recursion, and also the array methods, although not as much. You can do some pretty hacky things like appending to the array as you go. So I guess this is actually the same. For function call, or for function expressions, or function declarations rather, you have const f is equal to args. So you have arrow functions. So we can make use of that. And then same thing for this one. You also have arrow functions. This one is the question mark, and then for this one you can do const c equals a plus b, and put it into a variable. So how do we do this? So if you ever look this up on say the internet, Stack Overflow, you have this one, and the ones that I had immediately thought of is new f, which is a form of the object constructor creation. What am I trying to say? Basically, you don't actually need the parentheses if you have no arguments that pass. So you can actually just leave these off if the argument list is empty. So you can do new f like this, and that calls the function. Also constructs an object, but you can just ignore that. There's also template strings, where if you put a function right next to a template string, it will call this with a few different kinds of arguments. So these are called tag templates. Templates MDN. And so you can do things like this. So normally you'd have a function like this, where it takes in the strings and then a bunch of arguments corresponding to the things that you pass into the template string. And so you have the string here, and then each of these spaces in between the arguments that you pass in are put into an array into strings, and then each of these goes into one of the arguments, or one of the parameters in there. So string, or in this case here, my tag here gets that, and then is a, and then periods as an array, and then person expression gets this, and age expression gets this. So that's one way of calling another function without parentheses. I discovered this via HTML. Is that the HTML that I know? Have a look. Hyperscript tag markup. Oh yes, it is. Yeah, so this is fairly common use of it, where you have a string, and then it using the tag template literal, or rather tag template construction, you can process that string to do stuff. Another common use I think I've seen this is to process CSS into actual CSS strings, so you can do CSS in JS, where the processor would parse the CSS and turn it into some internal format that the library uses. You don't even have to output a string, you can output, say, an object, like in that example. Or in this case here, right, HTML here probably returns a bunch of DOM nodes. So you can do all sorts of stuff with this. So that only gets you some of the way. Now there's also this one. Actually, hold on, let's go back here. Did we miss anything? Overriding the value of a function prototype, or in general, other objects. So a toString and value of, I'm going to show that here. Nope, don't put there. Node. So you can do, so if you turn this into a string, for example, if you turn the object into a string, then you get object, because that's what the object has internally defined as its toString method. But you can override this, and you can say that, say it returns this string here, and it will call the engine will find a toString method and call it. So you can do crazy things like, let's say s equals, I wonder if this works. I didn't actually test this before stream. It probably won't work. Yeah, I didn't think so. I need something else. JSON, not JSON. Well, in any case, if you have an object, you can override its toString method. That can be useful sometimes. Alternatively, if you turn this into a number, say with a plus here, you can use value of instead. And it'll run this function. And here you can return a number of some sort. And you see we have 5 there because we said 5 here. So those are 2 magic methods that the engine looks for. There's also a well-known symbol. I can't remember what it's called. I think it's symbol.toPrimitive. Yeah. So if you do this, it functions similarly to toString and value of. And I think it might internally call this for the prototype for the default functions. So if you override this, you can get both of them at the same time. So knowing a little bit of JavaScript internals can help here. So this one suggests as a generator, but this requires parentheses, so we can't do that. As a getter, this also requires parentheses because you're calling define property. As a tag function, we've already explored this one. As a proxy handler, it requires parentheses. We can't do this one. And as instance checker. So instance of actually is another one of those where you can override the has instance, and then you can override the instance of, you can override how instance of works, the operator. So it reminds me a little bit of how in C++ you can override operators. It's not quite as extensive as that, because I think in C++ you can override a bunch of operators. But you do have some flexibility to do that in JavaScript. Was there anything else here? But this is all still very limited, because how do you pass arguments into here? You can't really. With an arrow function, you don't really have this value. You inherit this value from the outside. But you also can't pass anything in here because toString and value of, they don't take arguments, or they don't pass arguments. So you actually can't get data inside, and we kind of need that. You can define a function. Let's call this f. Console log a here. And you can call this, well, you can define a function with one parameter without parentheses pretty easily. And you can also do, if you somehow find a way to make a, let's call this G. You can find a way to make a proper function, a full-featured function. You have access to the arguments special object. So the arguments special object here is an object that contains all the arguments to a function. So for example, we call it G123. All right, and we console log that out. So then we get inside the arguments object 0123. And so we can use this potentially to do a new function with a string inside. So we can do console.log arguments. I need to put that somewhere. Let's call this H. Now we do H123. Right, then we get the same result here. Arguments 0, 1, 2, or 1, 2, 3. But obviously this uses parentheses, so we can't do that. If we turn this into a template literal, so we make use of the tag template syntax, I think this should still work. Possibly. H is not a function. There was a way for this to work. Aha. I think I needed one of these. Was this it? Unexpected token. I'm missing. Where do I have a comma? Let me use var here. Does anyone spot the comma? Because I can't see it. I'm just gonna rewrite this. Console.log arguments. Oh, wait. No, I still need that. Okay. Hello. Return arguments. You know, I feel like I'm missing something. I don't think I need new here. That's maybe what it was. Okay. So we have a way to make a multi-parameter function by doing function return arguments here, or rather using arguments inside of this function. And you can do stuff like extract out specific arguments by doing this. Alright, so we take the first argument. Access Mario and welcome in. We're just exploring the possibilities right now of what we can do with without parentheses, and we're gonna get to writing, doing actual challenges afterwards. Right now, if I can go back, these are all the ways that we can possibly get around parentheses for certain constructs, but calling functions is the difficult bit. And so we can access specific arguments using or by indexing the arguments object, or because we can destructure this, we can do say ABC like this equals arguments, and then console log or return A, for example. And we get the same thing. So we have a lot of flexibility there. I don't remember if I mentioned this, but function, if you create a string, or rather you can use the function constructor to create a function with the string that you pass in as the body. There's a caveat here in that this only works in the global. The variables that you have access to only work in global scope. So if you have a variable inside that you want to access, you're going to have to pass that into the function rather than either pass it into a function or make it accessible in the global scope for the function to be able to access it internally. Which is not a problem for us, I think, because I don't think we need, I don't think we necessarily will need that, as long as we can pass things in. So that's how we can create functions, but there's still a problem of how to call functions. And that one actually stumped me a bit, because yes, you can do the two. Hold on, let's add the stuff here. You can do this value of, and actually this is toString, and you can do a value of, and then you can do. Actually, we can add function const f equals function some string here, and then similarly you can do that here. But again, as we said, this is very limited because we can't pass in any arguments. Now, if we do say function return this, and then we do say string, then toString, we define that, and we do this. Not convert object to primitive value. Value of NaN. Which makes sense because this says expected primitive, so we can't actually do that. We don't have to return this. We do console log this, right? We don't necessarily have to return this. We can just do return, say, 5 or whatever. It doesn't actually matter. Mission accomplished. Volts are almost certainly M10. Very good. Very good. This is all going over my head. Yeah, this is... we're doing a deep dive into to things that people really shouldn't do in production code, but that's the fun part of it. But if something you're interested in, or if something catches your interest and you aren't sure, feel free to ask, and I'm happy to explain. Even if it does put us on a bit of a tangent, but that's okay. We're here to learn anyway. So we return null or whatever, it doesn't actually matter. But this allows us to have one argument, namely the this function. Or this argument, rather. This, of course, being, say you have a... how shall I explain this? They have an object like this, and then you call that... Well, let's actually put this on an object. All right, so you have that, and then you have s dot say function, or f is equal to a function. It has to be a real function here, because otherwise arrow functions don't get a this argument or this parameter. And console.log this, and then if you do s dot, if you call f on s, then you should get the argument back. And so this is going to be useful, say, if you do, say we call an a function here, or let's say f2. Let's call this f2, and we define a method on s called f2, where this is a function that returns, say, 56, sure. Return 56. Then if we do s.f, we should expect to see 56 because it calls the f2 function that's defined on the same object, and that returns 56. And we return the result of that. If we add this on a different object, say t, t equals an object, t.f is equal to s.f, and t.f2 is equal to a different function, say returns 42 instead, or 64, sure. Again, did that again. So we have the same f function from s, and then if we do t.f here, we should expect to see 64 because it's the f2 function of this object is different. Okay, so that is one way to get a what is it? That's one way to get a single argument. And you could technically package this by doing, say, so value of as a function, and then you have this here. But also you can do, say, a is 1, B is 2, C is 3, so on. And then you can console.log this, and then you can do, say, like this.a, and we would expect to see 1, because inside of this we do have in the object all of these named properties, which we're effectively using as parameters. So you can attach data to the object. Of course, we do have the side effect of having this, but we can always deal with that by adding a void there so it doesn't return anything. So we're basically calling this function for its side effects. That is one way we can do that. But there's still a problem. How that only pushes the problem down by 1, because while you can call this here, how do you do anything else inside without using parentheses? And so that's where I got a little bit stuck and search for a way. And then I found this article here. Or I'm going to send this Stack Overflow link so you can read this yourself. And then I found this article that outlines a way to do it. And that actually works. So there is this option here. This is basically a spoiler to part of the article. You can abuse the sort method on an empty or the sort method of the array prototype, and then you can use call, which is a function on the function prototype that lets you call the function with various parameters, and then you can use a template string on that. So we go over the ways here, the other ways that we've seen here. So tag templates, we've seen that one. Throw on error. This one is browser specific. Function, and then this, which is sort of what we had, although it's a little bit more complicated. I think it explains it down there. Let me make this a little bit bigger, actually. And then you have the instance of hack that happened there, and then you also have value of, as we saw before. And then new as before, and I think this uses browser stuff, which we can't use because we're working in Node. And as before, we can access the arguments using this. And so, as we saw earlier with the template literals, because you have access to all of the arguments as part of the function, right? So if we say define just a regular function here, let's call it, I don't know what letters we still have left. Let's call it U. Right, we just return arguments to so we can see what this is, and then we do U pass in A1, B2, and C3, and D, or just so we can see what this looks like. And as we can see, our arguments here are the array of strings as separated by the arguments there, and then the rest of the arguments in order. So that is also another way of getting getting arguments into our function. However, you do have to work around the first one being the string here, which probably isn't what you want. You probably don't care about this one. So one thing you could do is say a function, so let's call this U, we can still call this U, I think. If you have the arguments, what you can do is const and then ignore the first one, and we can destructure this and ignore the first one, and just take the args from the rest of it. And then you console log args, and then we do the same thing again, and then we get the arguments out again like that. Or we can destructure this if we want, or spread this if we wanted to get them all as individual arguments. That's fine too. However, if we try to do this with a call, so say we do what this is saying, and we do this, and instead of doing alerts, we can give it the U function that we had here. Alright, we get uncaught type error, cannot assign to read-only property 0 of object array. I assume this probably has something to do with the abuse that we're doing, because it's expecting an array of some sort. So if we look at the MDN page for array.prototype.sort and the array and the page for the MDN page for function.prototype.call, which are the two functions that we're interested in here. Right, so sort expects a comparator function, which kind of don't have. And then for call, the way you call this is you have a this arg, and then you have the rest of the arguments afterwards. And so by doing this, by having a tag template, we're actually passing this as the this argument, which is probably a little bit problematic. This is the array of strings. Probably don't want to do that. However, we do also have the option of reflect.apply.call, which is a little bit nicer because this is what it's actually meant for. So if we do mdn reflect.apply, now reflect here is basically metaprogramming in a sense, where the reflect object contains methods that allow you to basically mirror what JavaScript does in a sense. So you can use it to call other functions in our case, or like do things that JavaScript would do. So let's say you have here apply, construct, define property, delete property, get, all that kind of stuff. Things that you would otherwise use regular JavaScript constructs for, you can do with reflect instead as a regular function call. So reflect.apply is a way of calling a function, and we have here the target, which is the function that we want, this arg, and then the arguments to pass to it. And then because this is a function, we can also use its call argument. So we have the this arg here, and then you have the rest of the arguments here. So one thing what we can do here, instead of using sort.call, we can use reflect.apply.call. And this is still going to give us a bit of an issue, type error, because create list from array like called on non-object. I mean, this is probably the same issue as we had before, but this is because it requires 3 arguments, or 1 argument? No, multiple arguments. So the target, which is the function, so in this case u, this arg, which in this case we can do null, and then everything else afterwards. Right, because we actually need to give it an empty parameter list, empty argument list. You actually gave us what was it? Oh yeah, because we had to define as that. So if we give it arguments, say 1, 2, 3. Oh, I'm missing one. You need to redefine U. I'm just gonna give it arguments here. So I can get rid of all this. We get this, and we try this again. And now we have a way to call arbitrary functions with an arbitrary number of parameters, or an arbitrary number of arguments. And because this is general enough to work on every function, we don't need all the other hacks. And so to simplify this, we can make a function called call. Call is equal to function reflex.apply.call, and we have to escape all these because otherwise it will break out of containment here. And then we can do a little bit more here. We can get from the arguments, as before, we skip the first one because that is the tag templates, or the strings of the template rather. And then we can take f as the function, and then we can pretty much ignore the null if we wanted to, and just fill it in. If we don't need this, we probably don't need this value. So we can just take the rest of the args and do that. And so we can do call f, and then we can hard code in a null, and then we can put in the rest of the args as an array, as it already has. So the rest operator here collects them all as an array, and so we can just pass that in directly as the array here. Args is not defined because I did not do what? Right, because I need to escape these two. So now we have a call function, which we can call with a as a tag template, and we can do, say, U, which we had before, and now we can just pass in, say, 1, 2, and 3, just like that, as our arguments, and we get this back, as we should expect. So now we have a way to call a function just with a little bit of extra syntax. And so we can use this. We're going to do hello world.js. We can do all that boilerplate there. So we had call, or const call is equal to function, then this whole mess here, reflect dot apply dot call, and then another set of inner templates here. And we do the whole destructuring thing, so const skip the first one, get the function, and then collect the rest in an args variable. Pass in the f here, pass in null for that, and then pass in the rest of the args. So this should allow us to call various functions. And so for our hello world, we can do call console.log. And thankfully we don't need the this. So we call console log hello world. I think that's all we need to do. Okay, apparently not. Cannot access F before initialization. And that is because what did we miss? Did I miss a level of nesting? That's entirely possible. Not call F before initialization. Eval 122. I mean, we know that this is it. Do I need to doubly escape this? I don't think I should. Oh, it's not quite right. Oh, you know what I forgot? No, that's not it. I forgot the arguments thing. Bought a small trash can. Ah. I hope you enjoy the trash can. Yeah, I actually have a small trash can over in my living room. And it's just me here, so I don't actually have a use for it. There we go, so we have hello world, and let's actually format that. In the usual way, you got a comma and the exclamation mark. And so, hello world, we print that out. We are good to go. Snow print add hello world without parentheses. Okay, well, that was the easy one. Well, easy after we got the call. Well, this one's going to be a little bit more difficult. So we're going to do, as usual for these kinds of strings, FizzBuzz. I needed one in my living room and happened to find one that matched the color scheme I'm trying to go for. Ah, yeah, very good. The other week I saw a video, I think it was by Answer in Progress, where they talked about the millennial gray and how the space several years ago were just gray and fairly colorless. I don't know if I've ever... I mean, admittedly, I did buy a gray bedsheet because it was the cheapest thing on Amazon. But I don't know. I don't think I particularly have a preference for color or no color. Okay, so we have this. The bedsheet that I had before was actually a more of a beige color. I got from IKEA, but that one apparently it was too thin and ended up ripping, so I had to get something else. So what do we have here? We have FizzBuzz. I'm going to actually go back to the debut, not the debut resume, debut interview FizzBuzz. This is one. We can cheat a little bit and go back to our initial thing here, because I don't think we necessarily need to reinvent the algorithm. We just need to rewrite this as without the parentheses. I'm facing the consequences of mostly black furniture now. It's tough to move away from without a total overhaul. Yeah, if you have one color scheme, then it's unless you actually full black might not be too bad, because if you have a bit of color, or if you bring in something that has a bit of color, you can find a way to make that work, because it'll pop, but you can make it pop in a good way. Okay, I feel like this might be a little bit too trivial to move over. So FizzBuzz, for those of you who are not familiar, the task is to print out numbers from 1 to n, but every number that is divisible by 3, it gets replaced with fizz. Every number divisible by 5 is replaced with buzz, and every number that is divisible by both is replaced by FizzBuzz. So you end up with the sequence 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz. I mean, I could just run the program. It's 10 and 11, fizz, 12 is 13, 14, and then fizz, buzz at 15, and then the cycle repeats. I'm also introducing natural wood accents, but then you need wood colors that don't clash. Yeah, that makes sense. I don't know. I feel like I don't really pay attention to my colors. I just get whatever. Also don't buy furniture all that much either. Actually, my what was it? The couch that I have is a hand-me-down, and it has mismatching cushions because the frame for the couch was from one couch, and then the cushions were from another couch, and so it's a bit of a Frankenstein couch, and the colors don't match at all, and they don't even fit that well either. So I think I personally am okay with function over visuals on this one. I was gonna say form because that's how the phrase works, but the form actually is probably kind of important. Because if the couch doesn't behave like a couch and is not quite to form, then I don't think it's a good couch. Anyway, we can create a function called FizzBuzz. Actually, we might not even just do a function here. So I have this because we have it for testing. I don't think I'm going to bother with a test runner on this one. So we might actually just do it all straight in here. Const n is equal to, let's say, 35. And we can just change that. Usually for these challenges, I make an exception for the for some of the boilerplate code. So we could actually define a FizzBuzz function that has the parentheses like this, but I think we can manage with that this time. Because really the rules just say in the challenge code, and so everything before the challenge code and everything after the challenge code can be whatever. And I would say the n here probably is outside of the challenge code. So I can turn this into process.argv1. And we can make this a number. I think that's how you call it. Console.log n, just to make sure that we have this right. Apparently not. 2? 2. Yes. Because Node calls it, I think arg0 is Node itself, and arg1 is the file, and then everything else after that is the arguments to the application. So technically, actually, we don't need to make this outside, because we can do call and then number. Oh, don't do that. We can call the number, and then we can do process.argv to here, like that. And if this isn't anything, or rather, if this isn't anything, I think this is correct, yeah. If this is anything, we can give it 35 as the defaults. Which I don't think we need. Does this not work? Can we actually not do that? Hold on, let's do this first. This might actually be harder than I thought. If we can't use a number constructor like that. Should be able to. I don't see why you couldn't. Maybe it's just on regular functions. Not that this isn't a regular function. Interesting. Okay. In any case, I don't think we need n to be configurable, so we're just gonna make it 35. So that's fine. It may actually, I wonder if it is actually useful to have this. Yeah, it might actually be useful to have this parameter. So I'm going to call this, where instead of taking everything, we can accept a t for this parameter here. Or we can do a bit of a hack here. No, actually, no, we should be able to do this. If we do give it a t, I was thinking of doing something like, say, some array, for example, and then call this is equal to, or rather, let's say a is an array, and then we do call this is equal to all this, and then you can now do a.call this. And then you can pass in whatever you need to, and it'll automatically have this argument there. Or rather, this is call. You can just have this here. I mean, you could do that. I think it's a little bit roundabout though, but you could do that. In any case, we need, normally we'd have a for loop. So for let I is equal to 0, or I is equal to 1 in this case, I is less than or equal to n, I plus plus. Obviously we can't do this, so we need a different way of doing this. We can do recursion. Or we can do an array. In this case, because we are filling in an array, we can do this one here. So we'll define a FizzBuzz single first. This seems like it should be the easiest to do. So const FizzBuzz single is equal to a function that takes in an n. And thankfully we can actually we can't just copy and paste the whole thing. We can almost copy and paste the whole thing. We can do if 3, we can do this. Then FizzBuzz. Else, if it's this, There's got to be a better way of formatting this. Else if it's this. Then it's buzz. Else it is n, but as a string, which we can do pretty easily with this instead. So we've rewritten FizzBuzz single as that because a bunch of if-else chains, it's very easy to turn into just a ternary if all you're doing is producing a value, which we are. There's got to be a better way of formatting this. It's fine. Don't worry about it. Because I think it would actually do this, but that is also pretty awful. Any case, I don't need to worry about that. So we have FizzBuzz single as our helper function, and then we have. We don't need to turn this into another function, although we could if we wanted to, because we could just do another one of these, but I don't think it's going to be necessary. We can do a call on array and give it n. So we can let the array be that array.fill, and this is where this version will come in handy. Because then we're going to need to call this with our.fill. Using the array as this value, and then we give it 0. Just translating this over here. And we can pass this in as array. Actually, I think fill does modify the array, so I might not need to do that. Array.prototype.fill. The modified array fill with value is a mutating method, so that's what we're looking for. Mutating means that we don't. It will change the original, so that we don't actually need to reassign it to array here. So we fill it with zeros, and then we can map this. And call this array.map. Let's first make sure this works. Debug 1. Debug 2. Not read properties of undefined reading fill. So yeah, this apparently doesn't work. But did the other one work? Debug 1 as undefined. Well, that would make sense now, wouldn't it? If the array... Oh, you know what? I think I forgot. I need to return. That would help, wouldn't it? Yes. Return the results of the call. So that is transparent. That was the issue earlier that we couldn't get. It wasn't returning. Okay, so we have 35 empty items. Now we can call this. And now we have 35 empty zeros. Very good. Which means I can now actually do the thing that I was doing earlier here, where we can do call, what was it? Number with process.argv at 2 or 35, just like that. And I got rid of all my log. Okay. I'm gonna assume that works. So after that, then we can do a map. Array is equal to call this with array.map. And unfortunately, we're going to have to do something else for this one. FizzBuzz single at this. So we need to pass in a function that we don't have yet. We need to give it 2 parameters. But with this syntax, we can only give it 1 parameter. The easy way to do this, I guess, is we can create a function, define a function like this, and then we can give it return FizzBuzz single. I'm not particularly happy with this because it requires extra nesting, but it will work. So we can call it like this. We call FizzBuzz single like that. And give it arguments the second. Because as we see here, we don't care about the first argument, but we do care about the second one. And we can add +1 to that. And cap that off. And hope this works. Console.log array. Call is not defined because it can't see it, because it's within this scope. It's not on the global object. We do global this.call is equal to call, and we can get it to see that now. Is oh, that is a little bit I don't like that. As I said earlier, we can put it in the global scope. This was single is not defined, because we also need to put that in the global scope. If we use var, actually if we don't use anything, so we just do this, it'll automatically put it in the global scope. So if you assign to a variable that doesn't exist, and you don't use var letter const, it'll put it on the global scope. So that'll work. 1, 2 fizz, 4 buzz, fizz, 7, 8 fizz, buzz, 11 fizz, 13, 14 fizz, buzz. That does look like it works properly. But I also don't want to put these in the global scope. So we'll find a way to not do that. And that is a little bit problematic because call also uses a function. And to be able to do that, you need to pass in... hold up. Let's pull this out. Let's say call single. So we can construct a function that takes in a FizzBuzz single, and whatever else do we need? A call, I guess. So we can call call single with what are we looking at? Call this. Do we need call this? I don't know if we need call this. We at least need call and FizzBuzz single. We can give it fizz. We can give it call, and we can give it FizzBuzz single. All right. So now we know that we need. Now that we have a function that takes in all of these. We have a function that needs to return another function. So const call FizzBuzz single, those arguments, return call, and then this stuff. So that should hopefully give us a function. Oh, actually no, I need a closure. Oh, that's not gonna work. Actually, I'm complicating this. We don't need that. Do we? I'm thinking. Okay, so the problem again is that inside the function body where we have a string, it does not have the required scope to see the functions that we need. So we need to find a way to give it those functions so that we can call it. Also, I just remember the template strings can have new lines, so we can actually just format this nicely. I've discovered an order thread adapters instead of returning the legs I bought. Ooh. Which I assume only works if the... Actually, no, it could work either way. I guess it would look nicer if the new legs were... If the bolts on the new legs were thinner than the old ones, but interesting. I suppose it could work either way. Finding long enough legs with the right bolt is very difficult. Yeah, I can imagine. Okay, so what do we have here? So this is a function that takes in the two functions that we need, and then we need to call that right? The discrepancy is smaller than I thought it would allow for an adapter. Yeah, I wouldn't have thought that you can make an adapter out of that too, but I guess it's thick enough. We need to. The problem is, I think we need to wrap this in another layer, and we don't have another layer. Because this is a string. And if this is a string, that means that we end up with the same problem again. And we can't have that. Geyser, welcome in. Thanks for the raid. My name is Penbu. Okay. Start over. Hello, raiders. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux. And today we are taking on a programming challenge where we try not to use parentheses in JavaScript. And it is proving to be a little bit difficult. We're working on the FizzBuzz program right now. where you print a bunch of numbers and replace certain multiples with the words fizz and buzz, which we have the code for here in regular JavaScript, but we're trying to translate that into no parentheses. But yeah, I hope your stream was good. You were working on... Oh, I guess it was just chatting. How's that? You know, business staring back at me. Yeah, the Curse Coding is a series that I would like to do more. It was something that I had set out to do from debut, and I did a few streams of it. But the problem with this is that you need ideas for it, and I'm kind of short on ideas. And it's not only ideas for techniques, because I have a lot of ideas for techniques. I need things that I can implement those techniques on in a way that actually is kind of challenging, or actually useful. Not useful, but in a way that I can actually apply those techniques. So the thing we're stuck here right now is that the scope that is inside of this function can't see the required functions that we have. So the call and FizzBuzz single. We can fix this pretty easily by removing the const and putting them in the global scope, but where's the fun in that? So I want to see if we can try to get it so that we can pass it into the function as dependency injection instead. But yeah, guys and raiders, if you need to head out and take care of yourself or whatever, please go ahead and do so. And I should remember to give you a shout out because it's a thing that people do. There you go. Head to bed, alright. Well, good night. Energy has been low these days. Well, hopefully sleep will help with that. And also eating, probably. Eating is important. So yeah, what do we do with this? So I feel like with this, the call single, all we've done is push it down by one layer. So we have a way to get the arguments into the function. But I don't think you can actually get it to... Is this right? Wait a minute, hold on. Can you actually pass... Trying to think. Is it actually possible to pass it in directly? Because call is a call to function, which means you need to be able to pass the function in, which we kind of are. Actually, I want to... We can just test this out. Maybe it does actually just work. The types error string n of all this stuff. Because it's a string. Because this is now a string. Because we passed in a string to call. Hold on. This is why I don't like the nested thing. So if we get rid of the nesting, right, and we get rid of this stuff, then you get this, which I say is actually correct, isn't it? That looks correct. So why doesn't this work? Is it because we can't do... Can we not do nested calls like this? Is that a thing that we can't do? I doubt it, because we have the call and we have the function. Ah, wait a minute. Arguments plus 1. Arguments 1 plus 1. Right, because this is the wrong argument, but I don't think that's what this is complaining about. Yeah, that's not a function. It's being turned into a string for some reason, and that we can't have that. That's not what this is. That's not what that's for. I'm a little bit confused, actually. So this is being turned into a string because this needs to be... What was it before? Before it was a call... Actually, before it was just a... Before it was just a call single. Like that, straight. And we had this, where we return the call of FizzBuzz single and arguments, except we don't have this. So we expect to see FizzBuzz single in the global scope, but then we do this and it should... Oh, wait a minute, hold on. No, this is correct, because this calls... We are inside of the call function, or rather we are calling the function here, so we should get it here as call and FizzBuzz single. Yeah, console.log what we have here. Console.log arguments. Identifier call has already been declared. Oh, whoops. Gotta get rid of that one. Arguments 1, 0 is an anonymous function with the call function, yes. And arguments 2 is the FizzBuzz single function, which is also what we need. So why are you being turned into a string? So this is one level of nesting because we don't have... or rather, this is one level of nesting because we need an inner template. So we have this escaped, and we have this escaped. This we have escaped as well. Now we have escaped. So this should be, yeah. Again, as if we remove the level of nesting here, it should be that. Which, apart from this arguments list here, is not quite what we want. Oh, right, because this is calling that directly. Then this needs to return closure. Unfortunately, arrow functions don't have an arguments object. Right? Yeah, arguments is not defined in an arrow function. So we can't do that. And then this syntax is also not correct because you can't spread that because you need parentheses around them. And we can't use parentheses. Or not spread, sorry, it's a rest parameter. So we can't use that. It would be nice if we could just do this. Because that is what we need. We need to basically thunk this. Except this brings us back to where we were before. Look at what the function constructor gives us. If we can give it any scope at all. creates a new function object, which is what we want. .apply, .bind, .call to string. I don't think any of those. Can we give it an environment, a context? I don't think so. I mean, there's eval. We can maybe consider using eval, assuming this even works. Oh, ooh, wait a minute, hold on. I don't think so. We can't use... Can we do eval.call? With a null, and then what do we have in the so const ff equals console.log. Sure. So eval shouldn't be able to see this, or rather eval might be able to see this. If we use eval instead of function. No, but we need to create a hold on. Now we need to be able to create a function that takes in arguments. That's part of the problem. But if we do eval and then call this, hold on, we still have call. So we do call. No, but that doesn't work because we're inside of the function. And once we called call, then we're already too late. We've already lost the scope. We need eval on the outside. So we have a problem where we need to get the argument. We need to get multiple arguments. Or do we? We need to get multiple arguments, or at least get these in scope somehow. And then we need to inject it into here. Somehow. And I don't think using eval in this way is going to work, because it takes in a single parameter called script. And you can't pass anything else into it. It's not going to work. Direct and indirect eval. There are two types of eval methods, calls: direct eval, indirect eval. Direct eval, as the name implies, refers to directly calling a global eval function with that. Everything else, including invoking it via an alias variable, via member access or other expression, or through the optional chaining operator, is indirect. And I think indirect might actually... Indirect eval can be seen as if the code was evaluated within a separate script tag. Oh, that's okay. Which means it's basically the same thing as our function scope that we had before, and that is that doesn't solve our problem. So eval is not going to be a solution, because in our case it would be an indirect eval. And we have no way of Actually, hold on. Is that true? Is that actually true? I was gonna say, because can we do something like this? Where we do that, but I don't think we can. I don't think that makes sense. Because if you can eval at the top level, you can just run the code directly. So what I don't understand, sure, hold on, yeah, so what we need here is that we need a way to thunk this. Mr. E, welcome in, what am I making? We're trying to implement FizzBuzz, but without using any parentheses. The only time we've used parentheses here is just for debugging, just to make things easier. But otherwise, no parentheses allowed. And FizzBuzz, for anyone who's not familiar, if we go back up here, because we did run it successfully earlier. You print out the numbers 1 through whatever, replace all multiples of 3 with Fizz, all multiples of 5 with Buzz, and then all multiples of both of them with FizzBuzz. Otherwise, just print the number. Have I had a job interview with this problem? I don't think I have, because I think by the time that I started interviewing for tech, it had already become a bit of a meme. I don't know. It's one of those problems where it's too widely known for it to be a good filter. Finally home, welcome home. And as a filter, it doesn't actually. I'm thinking about this, and what if your interviewee solves this or doesn't solve? I mean, if your interviewee doesn't solve this, then sure, don't hire them. But if they do solve it, is that enough of a strong indicator to say that they're fit for your standards? I don't know. Maybe they could be. Maybe they could. Maybe not. There are more complex puzzles out there if you're going to do this kind of thing. The filter is now to write a for loop without AI. I had interviewed someone who was very reliant on AI, and it felt very weird. Of course, we didn't end up hiring them. But actually, in JavaScript these days, you don't really, unless you're working on things that require high performance, you don't actually write for loops all that much anymore, because most of the time you're working with arrays. And if you need to loop through a collection of things, you are going to end up turning something into an array, and you can just loop directly over, or you can just iterate over that array directly using the array iteration methods. The few times where you need the for loop outside of performance, outside of code that requires performance, is maybe if you need an early return, because you can't do an early return if you're using those iteration methods, unless you do hacks like throw, but then you're doing a hack, and I would rather just use a for loop. So the thing is, we have a way to thunk this, right? Okay, so just for the sake of arguments here, all right, so we turn that into that. We do this. This should give us the thing in the scope that we need, right? Unexpected token. What am I looking at? Where am I looking at? line 8. That's not right. That doesn't even show. Well, hold on. What? There are only a few places where we have a right parenthesis, and that is none of those. Oh, right, because we need that, of course. Put the brace on the wrong side. Yeah, so, well, I mean, it doesn't work to begin with. Why is that? Because the return function, I didn't actually return anything in here. So this is what we want, except we can't do this because those are parentheses here. But at the same time, we can't do a call or we can't do the same thing as we did before here, where we add a function like so, and then we double escape everything here, because then we end up with the same problem again. How do you get these variables into this scope here without putting them in the global scope? And maybe the answer is to put everything in the global scope. I don't know. But there's got to be a way to do this without doing that. Now, one option might be currying, where you do. I mean, I don't think that's going to help, because you still need to call eventually. And then you just somehow pass in this and that into here, but that's just more indirect way of doing this, I think. JavaScript creating a thunk. I don't need Redux. Oh, sure. See if we can figure out a way to do this without I need a closure with extra arguments. And I can do that by doing .call. I can do reflect.apply.call. But then I would need to call that. Hold on. Because I can call this function here. Or I can call it on. No, I still need to get arguments. The problem is I still need to get arguments. I can do, hold on, or this is a bit of a hack. But what isn't a hack here? I can do this. I can augment the array with a functions property that has FizzBuzz single. And so, I can then do I can pass call single to here. And then instead of doing FizzBuzz single, I can do arguments 2. Because if we look at array.prototype.map, oh, this is awful. If we have array.prototype.map, it takes a callback function, and the callback function has 3 arguments, or 3 parameters. One is the element, which we're ignoring. The second one is the index, which we're using. And then the third one is the array, the original array that we're calling, that we're iterating on. Which means that if we attach something to the array, in this case array.functions.fizzBuzz_single, or rather, yeah, if we attach something to the array, we can bring the array inside and access things that we need through the array. So in this case, because we attach the functions property to the array, we can access the array itself using arguments 2, and then we can access the functions property here, and then we can access FizzBuzz single through that. And I think this should work. Call is not defined. So we do need to pass in call here. So this is going to need to be arguments 2.function const call FizzBuzz single is equal to arguments 2. We destructure that, and then we can just have call here. We can have FizzBuzz single here. So this is slightly different from what we had before, because then because we're not calling this function right away like we did earlier. We're calling this as a loop iteration. So the difference that we have here is that earlier we had call and then call single, and then call and then FizzBuzz single here, which means this would have run right away, and then it would execute this. But because we're passing in call single as a function, this is just defined, and so this will run when it needs to. In this case, when map calls it, and map will call it for each item. Yes. Which means even though this might look the same as what we had earlier, this is actually different because of the way we're calling it. So this should work. Or not. Call is not a function. Console.log arguments 2. Did I do this? Did I have a lapse in judgment? Did I think about this wrong? Okay, yeah, so this is the array itself. You have functions.call. Oh, right. Argument.2.functions. Yes, I kind of need to get access the property that I attached it on. Okay, so that should work now. And then what we can do is we can have const output is equal to call this on dot join with this value of the array, and then new line. I think that's what we had before, right? Actually, I think the test just checked to see. I think the test was just a. What was it? No, don't change that. Where's the test here? Where's the index? Yeah, I just console log the array itself. Actually, we should be able to. That should be fine. Actually, yeah, we can do that. Or yeah, we can just do this. We can join it into a big string, and then we can console log the output for that. Console.log, and we can just give it the array. Okay, so now this should work. But not the array, I need the output. There we go, that is exactly what we want. 2, 1, 5, and 15, 30. You got 2 counts of the FizzBuzz there. Very good. That only took like an hour and a half. An hour? Something like that. Now, I think we have time for maybe one more. I'm gonna go ahead and commit this. Gonna clean things up a little bit. Should be good. Add FizzBuzz with no parentheses. Now the other one that we've done previously is the Tower of Hanoi puzzle. And I think we did that in our object horror. No, not there. In our no statements. Which, yeah, this is maybe a little bit, maybe we don't actually need to do it this way. Although, you know, it wouldn't actually be too, I don't think it would be too difficult to translate this directly, because you have these. Oh no, actually no, that's kind of it's not great. Tower of Hanoi JavaScript Rosetta code. We're not here to solve the problem. We're here to solve the problem with very specific constraints. We're allowed to look at other code here. So you could do this. This is probably what you'd want. And so we can take our call from before. I think this might actually be easier than the FizzBuzz. So we can take the call from before, and then oh, you don't need all that. So if we take this code here and adapt it, so we're looking at a const move is equal to some function. Would be nice actually. We can just do a function here. Unfortunately, we're going to have to be inside of a string. How are you with spicy food? I can tolerate spice very well. I would say I'd probably moderate. Maybe not very well. I'd say moderately, because I don't like when things are too spicy. But I do like having a little bit of spice. I like to taste my food, not just pain. But most of the time I do add some chili peppers to my meals. Or sorry, chili flakes, not peppers, not whole peppers, just flakes. Yeah, we don't need the whole Y Combinator here. Okay. Why did I use single variable? Yeah, whatever. Single letter variables. I mean, this one does too. Which I know what this says. This is the number of disks, and then the source and destination, the spare. Got Grimmy's hot sauce. It's nice, more than I'm used to. So good. Yeah, it's, I saw Grimmy's hot sauces when they came out, and I don't know, I was kind of interested. Not enough to buy them, but I think if I ever got the opportunity to try them out, I would. Let me, okay. That is correct. I'm gonna give a shout out to Grimmy here. I don't watch her as much as I used to. I would like to more, but I think things just don't line up anymore. But she's fun to be. Her streams are fun to be in. I like her vibe. Actually, I think I initially found her. It was it a couple of years ago? Was it before I debuted? I think it was before I debuted. Pippa raided into her, and I was watching a Pippa stream, and then she spent the rest of the stream pretty much thanking or saying hello to everyone in the raid, because she does like to go through everyone and what was that? Yeah, go through everyone who followed during the raid. So, Pippa being a very large streamer brought a lot of people to her, and yeah, it took a while. Her regular hot sauce is nice. The ludicrous one is akin to edible pepper spray. I can't say I've ever had interactions with pepper spray. I think that might actually be legal here. Hold on, I just gotta check something. Alright, we're good. So unfortunately, move here is going to have to be a string function, which I'm not very happy about, but whatever. Const NABC. Actually, I should probably give credits to this here. Restricted to law enforcement by the looks of it. I see. Arguments. So we have a way to get our arguments out, and then we can do if n is equal to n is greater than 0. Then we move. Oh, that's actually a bit of a problem. Hold up. These are statements. These are statements. Can we, hold on. Can we access the, I want to try something. If we do s equals function, can we access the function itself? I think there's a way to get to the function itself, and I don't remember how to do this. function dot prototype. No, that's not right. Or for use against animals. Interesting. If you get a function out, I might actually know. Maybe it is the what's in the prototype. Not all function objects have the prototype property. See description. What does not? Instance properties, instance method, static method. Apply bind call toString has instance. Display name length prototype arguments color. Define getter, define setter has own properties prototype of. These are all object stuff. Prototype.constructor. No, that's not it either. If the prototype of a function is reassigned with something other than an object. Actually, hold on. Arguments. I'm looking in the wrong spot. I should be looking at arguments. The arguments object has a reference to the callee. If a function must reference itself, either give the function expression a name or use a function declaration. Arguments.callee data property contains the currently executing function that the argument belongs to. Now, thankfully, we are not in strict mode, so we can technically use this. I don't like that, but we can technically do it. However, maybe this actually calls for doing the Y Combinator after all. Don't know how I feel about that. In part because I can't remember how to read this. Oh, I'm gonna split it over here instead. Okay. So we'll extract out the Y Combinator. Because this is a function that takes in a function like this. And then I think that the problem with the Y Combinator is that it needs to be grouped. We need to be able to call this, which I don't know if we're going to be able to call. This takes in this argument here. And that takes in that argument there. Okay. So are we able to... And we can get rid of this set of parentheses here, maybe? What is this? Okay, this is an application of that. Did I mess up? Where are we? No, that's fine. So this is the thunk actually. So this is a thunk, and then this is the actual combinator. Actually, I can't remember if the whole thing is a combinator or what, but in any case, F is this. We can start with that. That's pretty simple. And then we have another function, G. We can have it call itself like that. I can't call it X. I need to call it something else. I can call it G. That does work. It's awful, but I call it G func. That's fine. Self apply. And then we call that on this stuff. On X, or whatever this is. Apply F is equal to X to, the problem is that we need this inside that. So we might actually have to do this inline. So we need to call F how are we gonna do this one? Because we need this inside of here. We could just, I guess, do this, but I need, this is a call. This might be a call recursive, where you have a function. I'm gonna move this over here. You have a function that's basically call. We're going to take this as our base here. You have a function that takes in call recursive. F this F. That's the recursive call. And then we need to call this again. Hold on. We can just do call. We're going to do call X on X. Okay. But we need a way to get X, which means that this needs to be that. But then we need to apply F to it. We need to do F, or call F on a function that calls X. And that is going to be a bit of a problem. Because it's context equals some object. Okay, so we can pass in a context with all the functions that we might need. And we can have that be this parameter. Okay. Call that T, because we called it T elsewhere. So we have a list of functions. So we have f, and we can take in the function that we need, so that's fine. We can add it to the context if we wanted to, I guess. With the self-apply, G is called GG. I think that one's fine. And then that gets X to something. We need to call F on, and then something that takes in the bunch of arguments, and then applies X to X, and then the result of that gets applied to the arguments. We might actually switch to doing a direct call to reflect.apply call, because we do have the arguments here as an array. As an array? I don't think we have this as an array. Hold on. Can we just make this a function? A function that takes in X, except we don't have X. I think that's the part of the problem. We don't have X. Return reflect.apply call. What am I doing? I just copy this here. We do have X, sort of. We can do a call. We don't have a way of getting call here. But sorry, this is behind my head. We can't have that. Now I had something going with the context thing, because you can pass in a context with all the functions that you might need, and pass it in as part of this value. But I think I'm starting to confuse myself here. So self-apply is this. I'm gonna work down here instead. Start over. So F to this is pretty straightforward. And then we have a call to the self-apply function, which is this. And that's fine. I think I'm missing a quote somewhere. We have a self-apply function there that applies to a function that has X. Now we just have to rewrite this. So this thunk here can be rewritten as a function dot call. Reflect dot apply return reflect dot apply dot call x on x no, that's not right either. Oh, this is so confusing. Reflect.apply.call, the output of x on x. I'm going to do that as shorthand first, and then we can expand that out later. And then it requires a this value, which we don't have yet, and then it requires the arguments. Is that correct? I think so. Yeah, so you take in all the arguments here. And so as the this value, I guess you can take in x. So then you can refer to no, this is wrong because I need to escape these, and that's not right. This is a function that returns reflect.apply.call the results of this. Let's call it null for now, and then the arguments. And so how do we get x into this scope? I'm trying not to use arguments.call because, well, we can. Probably not the best option here. So I have x. I have a function. Actually, hold on. I don't need to restrict myself to expressions because I can actually do returns. I have been making this more complicated than I needed to. So why do I need to do this? I can do expressions, or I can do oh yeah, because I need a recursion. Yeah. Okay. If I have a function here, I can have where did my thing go? Right, okay, it's over here. Although I think I may have accidentally put this in the wrong spot, and this probably should go over here. I'm confused. Where are we? So this refers is this. This is that. And then this is that. Which means that is gone. I need an extra one here. And then I need an extra one there to close that off. And then I need an extra one there to close this off here. Okay. And then I need to return this. Okay. And I can have the x in a context. So say const context is equal to, actually I might not need that. We can call, we can turn this into a call. If we do f here, and then we do a function application here, we can do that. And then we can pass in x as part of this. Except that's not going to work. I can do const arg is equal to this function here, arg dot x is equal to x. I can attach it to the object, or rather I can attach it to the function. And so now we have a copy of that, and then we can do argument.callee, which I would rather not do. But it would work. And then this is a context. So we kind of do need context though. We need this. We need call. We need call. We need x, and then we need const x call, and then x is equal to arguments dot callee dot context. Return, reflect, apply, call. We just do a call here. Oh no, x. No, yes, okay, call. And I'm going to need to double escape these, which sounds wrong. Possibly. You're inside of a... Okay, now we're too many levels in. too many levels deep. So we have a function. And this would otherwise just be x at x. Null arguments that. So this is evaluated directly, which means we can just replace this with a call with one level of nesting. I think. Like so. No, don't do that. Okay, I think this probably does it for that one. We're using arguments.callee for now, but we can try to figure out how to get rid of that later. I don't know if this is gonna work, because I think we're a little bit too deep into this, but oh, you never know, maybe. Off, see ya. All right. Well, good night. Thanks for dropping by. We're missing this, and then we're missing that. Okay, so I think this should just work. We have self-apply and we have the regular call. So that's the Y Combinator. And then we apply that to the Hanoi solver. So we can call this constant y is equal to this. And then the function is going to be the solver, which takes in an h, which is the solver itself. Solver is equal to this. That takes in a whole ton of stuff. We're gonna have to pass in a context. So what if this is a function? If we make this be a function, we can shortcut a little bit. Function. Okay, so we can make this argument be the function itself. So that's probably a way for us to get around that. Okay, const NSDP arguments. And then we basically just copy this bit here. And then we'll return that. But instead of H, we do this, and instead of H here, we do this there. So then we can do a call on this, that entire function. Using h as this value, and then the arguments discount source desc spare, which we got from the solver. Which we got from the test file. Okay. So we are just going to define that out here. Const discount is equal to, say, 3 for now. Const source. Wait, hold on. Yeah, that should be fine. We actually don't need. We can decide to not put these in. We only actually need the discount. We only need the discount because the other things, the source, dest, and spare, for the actual algorithm itself are defined here. So actually we only need discount. And then we can do, where are you? We can do this for the discount. We can do just n there, I guess. That's fine. Process argv2 will make that 3 by default. We don't want this to be too large. Okay. So the solver is that. So you pass in the, so the solver is this thing. And then you call, hold on, you pass in H. Where's H? I don't even pass in H yet. Where is this? No, you call this. Yeah, you don't do this yet. H is just a function there. That's fine, and it's just this. So that's the solver that's going to be inside of this here. And then we call outside. We call the combinator. The Y combinator with the solver inside. And then this goes into a thing called solve. Because that returns a function. It should return a function that recurses. And then that we can now call, hopefully, we can call with this. Our const moves is equal to call that. So we can solve with the discount, so n. N, and then hard code the source destination spare. So 1, 2, and then 3. Okay, we have not run any of this. This is probably not going to work the first time. I'm just going to console log out the moves for now, just to make sure that things are okay. Unexpected end of input. You just need to believe. You're not wrong. End of input, which means I am missing a... probably one of these. Yes. This is not a function, or its return value is not iterable. Okay. Why is that? It is because I don't have a call this. Where did I expect to have a call this? Because I expected... Where did I use this? Solver here. Wait a minute, hold up. It's not right. That's not right. How did I decide that we could... Self-apply. So Y is call self-apply. You take the F, you get the function there. And I can do a... Hold on. We can do a call this. We can do a call this there. So we can instead make this call this. And you do a self-apply calling that, and you do a call this. You can give it that. That's not really gonna... I don't think that's helpful. But It's worth a shot. So for this one, we pass in the function, and this value is the function itself, and then we pass in the function itself too. Actually, that might do it. That might be enough to do it. Apparently not. And you know why? Actually, no, that's not it. Oh, I think I might be very close to something. Hold on. What if we do this? We take this. Const f is equal to this. Or let's return all f dot bind. So bind will fix this value of the function. Function dot prototype dot bind. Gotta remember how to call this thing. This art, okay. And we can give it F. This actually feels kind of powerful. So basically what we did here is we took the function. Wait a minute, hold on. No, this doesn't work either. Hold up. Because we just stripped it of the bind. It's not gonna work, is it? Because if you do this, that's not gonna work. So let's say f is equal to console, or f is equal to function console.log this this value here. That's not gonna work. And then if you do f.bind, say b equals f.bind, right? And then you call b on f. Bind must be called on a function. Exactly. Can't do that. Can I eval? Is that a thing I can do? Can I eval? How do I bind this without... Wait a minute, hold on. I think I can call FF. Is that right? Hold on, I need H, not F. I need to call F on H. Is this how I bind things? No, that's not how I bind things. Hold up. That's not right. Because then I can do, I can't do that though. How do I bind a function? That's... Can I do something with reflects? I bind a function with reflect.apply. Static method calls a target function with arguments as specified. Target this argument and arguments list. F dot bind dot apply with this. Okay. It's very hairy, and I don't know if this is correct. If I call the apply function on this dot bind on f as the this argument, and then I can do as part of the arguments list. So now we're calling bind. We can call it with h. The function of prototype apply was called an object, which is an object and not a function. Which one? Any call? Is that what this is? Reflect.apply.call is not a function. Reflect.apply.call is not a function. That's... no. No, that doesn't make any sense. We've been using this thing the entire time. That doesn't make any sense. Reflect.apply.call is not a function, but then function.prototype.apply was called an object, which is an object and not a function. Except we're calling it on f, which is a function. Correct? Not correct? I don't know why that doesn't work. But if we do bind.apply, so apply function prototype.apply function.prototype.apply calls the function given this value arguments and for an array like object. So an args array takes in an array, which we do have. So if this value of the apply function is this, so we're taking the bind, right? So we're taking the function, the bind function, and then applying it to f, which is the function. Actually, no, that's not right. Apply this arg to h. So what's the function we actually need? So we need f.bind h, right? And in order to call that indirectly, we need f.bind.apply the function, but also h. Because we need to translate that and that correspond to each other, and this corresponds to here. And then to turn that into a call into one of our calls, this becomes call f.bind.apply, because that's on the left hand here, and then f, and then h, which is exactly what we have, except apparently that doesn't work because f is not a function. Is that what you're saying? I can instead of call, I can call this directly. Reflect.apply dot call, f.bind apply with these arguments. Like so. I can do that directly. Create list from array like called on non-object because I forgot to do null. Function and prototype applies call and null, which is null, not a function. So do I actually need to make this f? This is not a return. Okay, so we're getting there. In which case, I think what we need is this instead. Maximum call stack exceeded. Okay, well, we're getting somewhere. Why? Is it because we need a thunk of some sort? We don't actually need to run. We don't actually want to run this. We just want to run. We want to reply. Const s equals this console.log s. I need to see what this is. Debug s. Do we even get here? It's possible that we don't. What even is arg? Where do we see arg? Arg is all the way up here. That doesn't make any sense. We're already past that. Arg is equal to function const args callee. Well, yes. Yes, I mean, kind of is. This makes sense, I think. And then F is the solver. Debug 1. I expect it to go up to here. Because I think... Okay. Calls debug 1 a bunch of times. Because it recurses and it's supposed to recurse. But it isn't supposed to recurse this much. Why? Console.log this. Okay, I need to see what this is. Anonymous with a context that has call and X. Okay. arg.context is call and X. Which makes sense. Because that's what we have here. And X comes from here, which is fine. So I think this actually probably works. Debug this. Actually, maybe it doesn't work. Because this is an anonymous function that has a context, which means this is getting arg and not the function itself. Actually, H. Console.log debug h and h. This might actually be working. So if h is arg, and I don't remember if it should be arg. Maybe it does. Maybe it should be. H is the same. Okay, so H is the arg that we need. So this part is working fine. This part is working fine. We actually don't need this anymore. Because normally we do want it to be H here. So this lines up correctly. So now we just need to make sure that we turn this properly into a thing. And it's possible that we didn't. No, that's not gonna work. Because that doesn't work. Okay, so the arg here, arg is a return. Hold on, I don't need to make this all in one line. This is a template string. I can use my I can use the thing. I can use new lines for this. What am I saying? Arg.context is this. That's fine. Const y is this. Arg.context return.call. I can indent this once. Move this over here. I can call new. Hold up. Maybe I don't need arguments callee. If I call new instead of... Does that work? If I call new, then I can get a this value without having to use arguments callee context. Actually, no, that doesn't make sense because I can just call it with this value instead. Which means, actually, then I can do... No, because I need to apply it on f. F with call this apply self-apply x. Because I'm using arrow functions. I can't... Actually, hold on. What is f here? The y combinator, the f should be solver in this case. So solver is an arrow function. I can make it not an arrow function if I need to. But where do I even need this? Arg. Actually, hold on. I don't. Let's ignore this because I think I'm thinking of too much at once. We got a semicolon here. So we call. Does this need to be a thunk? Is that what this is? If we go here, vi this, z. Sorry, that's not the one. Vi this and zf to create the folds. Now we can just focus on this one here. So f, everything that's in here is in there. So that's fine. And the body of this is this whole thing. So that is, call this, so self-apply is this bit here, applying itself to itself. That's fine. Which I don't think actually needs a call. Actually, maybe it does. Maybe it does. So self-applies that. It returns a function. I actually don't exactly remember how this works. But it applies itself to itself. It applies this to itself. And so, you apply, self-apply, and then we give it the f as this, but it actually doesn't matter because this is a it's an arrow function, so this doesn't actually do anything. We can just do that, and that should work the same as before. I think. Yeah, we're still getting maximum call stack seated. So yeah, I think that's equivalent because this is an arrow function, and arrow functions don't get their own this value. So you self-apply, and then we need this, and we call f on this function here. Now the arg itself is a function that takes in a bunch of arguments, does that, and applies x, which we got from here, which is part of the self-apply, so that's that. We put that into the context of the function. Oh. No, is that correct? So it's a function that you later then return, reflect, apply, or calling x on x, and then null, because that's fine, and the arguments. Are you sure about that? How do you get back args? Actually, no, that's probably fine. Does this need to be in a... No, this... We call this immediately. As soon as we call this function, right, we call this immediately. Actually, no, hold up. No, this is that right? We call this. We invoke this immediately, and then we invoke the result of that with the arguments. So surely this is correct, right? Reflect.apply.call. I'm gonna give this x, I guess. That's fine. Function prototype apply was called on undefined, which is undefined, not a function. Which means x is undefined. I don't think it's correct. Why are we even doing this? I know we were doing this because we needed recursion. But can we do recursion another way? If we're already using arguments.calling.context? Alright, we're gonna try something else. I'm gonna call this Hanoi 2 so we don't overwrite what we had before. So I think the problem was that we needed multiple statements to happen in the function. Which might actually be fine. So function const move is equal to function this, right? Const n a b c is equal to arguments. And we can do a trick where we can do no, we can't do that. N is greater than or equal to 0. We can define another function. What do they call this thing? Continuation is equal to a function now we're deeply nested here. I'm gonna move this out so we aren't so deeply nested. So we have a continuation here. We can do we're gonna also have move here. Okay, so now we have a reference to our outer function. Then we need to just do call. I need more context. Can I get this with this value? I think I should be able to. Call. I need to do this, and I need to do this. This dot move. And then we have n-1, but this. And then we have a. I think I call this thing not ABC, but source, dest, and E spare. SDT. Why is it n-1? Oh yeah, because it's minus disk. Okay. Is this correct? What is ABC? Start peg, end peg. Move disk from A to C. Oh no, that's correct. Okay, yeah, that's correct. A to C. That's not quite correct. At least not for what we're doing. What did I put in the solver? I returned that. So if we're going to keep the same format, then it's going to be this. Actually, we don't need to keep the same format, it's fine. But we are going to change this from ABC to source dest spare. So we want this to be from the source to the spare. I'm going to call console log console.log from source to dest. And then we do another console log for this dot move n-1 from the spare to the destination. Yes. Okay, so in this way, it's not going to return anything. That's fine. We just need something printed out to console. So now we have a move function that can take in if so return so if n is equal to 0, if n is greater than 0, then you call continuation. Call this continuation. I need this dot call. And then this can have context is equal to an object that contains move, which is arguments.callee, which I don't like. We're gonna do anyway. Actually, I might be able to do just this. I can do this probably. It depends on how we call it. Which means this is going to be a call this for that. And I'm going to need to pass in this dot move again. I'm going to do a call self this, because I can automate the thing there. So we're going to take call as it was before. We're going to call this, and then call. You know, you can have another one. Call self this, where instead of getting a call or passing in this value itself, I'm going to pass in the self as this, if that makes sense. I think that works. Okay. So if I do call self this, then I can do call self this is equal to do I need that? Do I need that? This dot call self this. Does that actually work? Am I thinking about this wrong? Do I need to move this out? Move.context is equal to move is this, and then call self this is this. Okay. I'm not sure I like that, but it'll work. I think it'll absolutely work. It's a little bit cursed, but like I said earlier, what in this isn't cursed? Just undefined. Because we only need to run this for the side effect. And because we're not returning anything, this should be okay. No Hanoi 2. Unexpected token. Because I am missing this. Unexpected const. Or where? Is it here or is it here? One of those two. Well, we'll find out. The one that doesn't have it. Okay, it's that one. Why? This worked before. Can I do a let? Arg string terminates parameters early. Huh? This is destructuring, isn't it? Can I not do that? Okay, give me the function constructor again, because something's not lining up here. Function body arg1 arg2. Okay, and it's because I have forgotten to escape these. So what was happening here is that we were getting argument 1 argument 1 as an array with all the strings, and then argument 2 as the continuation, argument 3 as this.context. Which actually continuation I need to put into here. But this.context.continuation. Okay. So I should be able to get away with not using arguments to call in this case. I just needed to use a proper move. Okay, that's fine. We haven't actually called this thing yet. So call self this with move on. Actually, I only need n. Which we have. I'm going to take the n that we got here, and I'm going to put it on here. I'm going to take n. I'm going to do that. And I just hope it works. Call this is not defined because we didn't pass it in. All this is not defined because it's not in the context, right? What if we just once context is equal to call this this self continuation move, and then move.context is equal to continuation.context is equal to context. I can shorten that. Okay. All this is not defined. We're still right, because this needs to be this.context.call this. Which actually means that I don't need this.context anymore. If I call this on context is equal to all this stuff. If I do that, man, this almost feels like cheating. Because we're effectively creating a global without creating a global. This dot call this, and then this dot continuation, and then this. Call self this, then this dot move. Okay, that looks correct. Undefined to undefined. Okay, we're getting somewhere. Why? What's wrong with you? This dot continuation, because we need to call it with stuff. And it's going to be n 1, 3, and then 2. All this is not a function because actually do need this dot context. No, but that doesn't make any sense because we gave it context as the this value. Okay. Well, something's up. That's not quite right, but at least it isn't Stack Overflow. Okay, hold on. Move context has all of these in it. We pass in this value every time. We can do call this. We don't need to call this for that one. We can pass in this here, and then we can pass in this here. We're passing the context for everything. So this should still function as before. So, then it's just a matter of something's wrong with how... Called the wrong function. No, this is still correct. Hold up. We actually do need this then. SDP. Means we need to seed the values here. 3 and 2. Close, very close. N132 NSDP NSDP there as well. S2D console.log debug continuation arguments. 3 is undefined. Why? That should not happen. The second time around. Hold on. 3132. So NSDP. And it goes to this one. Oh, no, because we're missing one. Right, yes. That makes total sense. Because we're missing an argument. Of course, it's gonna not do that. There we go. That's what we want. Okay, I mean, this works for the printing case. It's not the Hanoi that we did here, but it does work. And I don't think it'd be much more complicated to change it to this. So we do it this way. I think all we need to do is do a return that. Do an SD and then do return this. And then instead of undefined, we return the empty array. I think that's what that says. N is equal to 1. Then we do that. I'm going to skip that optimization. We actually don't need that. Const moves is equal to this. And then call console.log on moves. Well, that should just work. Unexpected token. On which? Yeah, okay, that makes sense. So 13123213212313. That looks about right. We can format this a little bit better. we can do call moves or moves.map. And we need to call this moves.map on moves. Now we need a function. Okay, we kind of already did for the FizzBuzz. So we can basically just call this. What is call single? Call single is that. We need to format this as a joiner. Const format format something. Format move is equal to a function that takes in call console.log, basically what we had earlier by heads. Very carefully. So we take that, that's the format move, that's fine. Right, because we're gonna need to format. We can figure out where to pass in the context later. Actually, that's gonna be a bit problematic, isn't it? How do I do this for this one? Call single. Call single has this. It's not functions, right? Because I passed it in through the arguments. I passed it in through there, so I can get format move. Const SD from arguments 0. Context or const call. Const call from arguments 2. We're gonna do the same thing again, where moves.context gets the context. I call console log from this to that, as we've done before. Actually, no, this is not right. We just return a formatted string. Just a regular template string in this case. So SD and the call, we don't need this anymore, because we only need to format the move there, I think. We need to, so moves.map moves, and then we give the format move function. So this gives us a list. Moves const formatted moves list is equal to that. Const formatted moves is equal to call this. Okay, hold on. I'm missing one of those. Moves.map. I'm gonna map over this again. No, this is not. No, join. moves.join, which I think we already did here too. We're gonna do that, but instead of array, we can do moves lists. We're gonna get rid of formatted moves list here and just call this moves list. And then we can do output. And then this should give us what we need. Undefined is not a function because we called something incorrectly. Where? It's one of the call thises though. Undefined is not a function, it's because of this here. Yes. Because, gotta make sure it interpolates. So this should work now. 1 to 3, 1 to 2, 3 to 2. Okay, we can double check this. Towers of Hanoi. I think this is what we used before. So 1 to 3. I'm gonna move this over here. I should be able to see that up there. So 1, 2, 3, 1 to 2, 3 to 2, 1 to 3, 2 to 1, 2 to 3, and then 1 to 3. Okay, this works, and we didn't have to use arguments.callee, although I'm a little bit hesitant about this one. Do we actually need to put it on the... I don't think we actually need to put it on the actual functions in this case. I'm gonna try without and then see what happens. We might not need to do that. We don't need to do that. Okay. So this is still a little bit iffy, if only because we're basically creating a context that knows of all the functions, which is fine, I guess. If you were to do it with the Y Combinator, you wouldn't. I don't think you'd need to do that. Maybe. I mean, this gets a little bit hairy, so I don't know. Maybe you would. But I think that does that. So, is it possible to write JavaScript without parentheses? At least for the cases that we have explored, yes. There may be more, and I don't know if it's possible to do everything. I don't think it is, because you have generators, and you can't really. I don't think you can create a generator like you can with a function. Maybe, because I know the function generator is not an actual. What do you call it? It's not an actual constructor, so you can't actually do that. Getters and setters you might be able to, because you do have the define getter, define setter as functions on the object. Yeah, there's a lot of things you can do, I think. And you might be able to count the number of things you can't do. Yeah, this is I would say it's if you like this kind of stuff, it's a good exercise to try. I would recommend. It's fun. But I think I'll call it there. I just realized that I do need to change something. Oh, I can just show it here. Never mind. YouTube.com. Penbu VT. It's this one. Next stream is going to be Composing 101 with Five the Neutrophil. This will be on Friday. So if you've ever wanted to learn how to compose, or if you ever wanted to compose music but never knew how to, this is definitely something to watch out for. It's going to be at 2 p.m. Eastern Time. a few hours earlier than usual. So watch out for that. No, don't do that one. And then on the same day, whoa, YouTube bug. Nice. On the same day, we're also going to have piano improv closer to the original time, or close to our usual time. This is going to be at 8:30 p.m. instead of 7:30 p.m., so an hour later than usual. Both of these will also be streamed on Twitch, so if you're over on Twitch, you can watch there. Yeah, this first though, that's going to be at 2 p.m. And then this one at 8:30 p.m. Okay. Am I missing anything? Possibly. For those of you who are new here, my name is Penbu, the programming, puzzle gaming, and music making VTuber on Linux. And for those of you who followed on Twitch today, thank you for the follows. We have now reached 200, which now unlocks the 200 followers special. Since we've reached both 200 on YouTube and Twitch. So watch out for that. That's going to happen probably in the next couple weeks. I need to figure out when to fit that into my schedule. But we are going to be doing Windows Classic themes, so watch out for some instructions for how to submit your color palettes. Is that it? I think that might be it. I've been streaming for how long now, and I still don't know how to end properly. Well, anyway, for those of you on Twitch, we're gonna find something to raid. For those on YouTube, so stick around. For those of you on YouTube, just if the person I find is dual streaming, I will manually send you over there. Regardless, if you are not in the Discord and you would like to, we do have channels for programming and music making and all that other stuff. So there's the invite link if you'd like. And then all of this Penbu VT is going to be uploaded to GitHub in the Cursed Coding repository. So if you'd like to see the code that we produced, it will be up sometime after the stream. Hopefully very soon. I need to commit all this stuff too. Okay. Twitch is going to go into ads, so I will go find somebody to raid, and then we'll raid out after the ads are done. I think that's it. Thank you everyone for coming, and good night. We'll see you next time. And that's going to be Friday, not Thursday. Actually, there will possibly be a Discord stream on Thursday. So if you're also interested in that, we're going to be reading the Ko-fi terms of service. Now I think it's important to read terms of service and stuff like that, so we're going to be doing that because I do want to set up an account at some point. I have some plans that would benefit from an account. Anyway, enough stalling. We're gonna go. So Twitch, once again, stick around for the raids. An ad's gonna happen in about a minute and a half. And we'll raid out afterwards. That's it. Thank you all for coming, and I'll see you next time. Good night. Bye. Twitch is almost out of ads. Oh, a couple seconds left. Seems to be kind of difficult to find people. Oh, Twitch, welcome back from ads. I was gonna say, it's kind of difficult to find people, but I think I found somebody who we might be able to raid. I'm looking at Bigman247. Hold on, actually, I should double check if they're streaming on YouTube as well. Oh, yes, they are. Okay. So YouTube, you can join in on this too if you'd like. Anyway, Bigman247. They seem to be doing a game called Celestial Crash. It seems to be about celestial bodies or whatever. But yeah, I mean, I saw planets. I'm sure that's gonna be fun. Not Shadow, Raid. Raid is what I need. This one. Yes. For those of you on YouTube, if you want to follow along, they're also streaming there. This is the raid message. If you'd like to participate, and go ahead and copy that and paste it in when we get there. Yeah, I've never seen them before, but fellow dev, you know, can't go too wrong. Oh wait, oh that's it. On YouTube again, you're gonna have to go there yourself because I'm not yet at 1,000 followers and you need 1,000 subscribers. I call on YouTube. Yeah, you need 1,000 subscribers to properly to redirect out. So you'll have to go there yourself. This is not JavaScript. What are you working at? Or is it a for each? This. What? I don't know. Anyway, have fun, and I'll see you next time. Alright, bye.